So it is finally here, the second part for our complete course for the GMAT quantitative section. You already know what you're gonna get, of course, because most likely you already watched the first part of our complete course. So you're getting a free PDF with 100 questions and anything else you can dream of in order for you to get a really high score on the GMAT quant section. Okay, so stay tuned. Now, if you haven't done so, I will invite you to subscribe to the channel and click on the notification bell. Alright, also give us a like if you find this video useful. That will help us grow and also will help you grow as well, because if you are planning to prepare for the GMAT, you better watch our videos. Now, if you're thinking about preparing for the GRE, maybe taking the GRE, or you know somebody who is about to take the GRE, well, good news, because we are preparing a complete course also for the GRE. So there you have it. Okay, Merry Christmas for you. And one thing I do want to tell you though is when we watch this video, just like the last video, okay, this video is made in such a way that you're going to take the most advantage. You're going to get the most, you're going to get the most advantage. You're not going to take advantage. You're going to get the most advantage, the most benefit from this video by watching every single second in order. Okay, I know a lot of you guys want to jump around places, right? In this video, you have to know, the chapters, the theory builds on top of each other, right? So you first have to watch the first theory and then the second and the third. The whole GMAT is like that, okay? So if you truly want to get the most benefit from our videos, watch every single second of the course. Before we start, also let me tell you, we have an ongoing competition, all right, called the Biggest Liberty Fan. Basically, we have two prizes going to our most active subscribers and followers in all of our social media, not only here on YouTube, but also on our Instagram, TikTok, and Facebook pages. The two followers who are the most active will get these prizes. Now, if you want to learn more about the instructions for this contest, then go to our previous video because we explain them there. Now, also, don't forget we're offering a free PDF with 100 GMAT questions and video explanations. So just go there to the link in the description below, and you'll go to our website and you'll be able to download it. All right, so now let me tell you something even more important. For those who want to stand out and are looking to get a really high score on the GMAT in the fastest and easiest possible way, Liberty Test Prep offers the best private GMAT tutoring, 100% practical and customized to fit your needs. All of our prep packages include full access to Liberty's GMAT classroom with a huge database of almost 5,000 exercises, tons of mock exams, and exclusive theory and practice videos that will help you achieve an outstanding score on the GMAT. You can visit our website to learn more about our services or get in touch with us directly via WhatsApp or Telegram. During this sales campaign, you can get your first introductory GMAT class for only $7.90. So here's what we're going to be seeing on this video. Okay, so these are chapters. Again, don't skip them. Just go and do in order. So now we're going to start with chapter number 4. Chapter number 4, statistics. As I've mentioned before, the statistics on the GMAT is kind of basic. Okay, usually problems with the mean, the median, and the mode. Sometimes they do give you a problem with a standard deviation, for example, but they will never ask you to calculate the standard deviation yourself. However, there are some shortcuts that you must learn in order to comply with the time. So watch this section, watch this chapter carefully. Okay, so now we start with the chapter of statistics. Okay, statistics is a big thing on the GMAT. Okay, the first thing we're going to see, and the most important by far, will be the concept of the mean. What is the mean? The mean of a set of numbers is defined by the sum of all those numbers, the sum of the elements, divided by the number of the elements. So the mean, the same thing as when they say the average, right? Average, it's the same word, basically. The sum of the elements, which is also, if you've read any books, you have that, right? The sigma thing, sum of the elements divided by the number of the elements. Pretty simple, right? Very simple. So what is the mean of this? So what you do is, what's the sum of this? 2 plus 8, 10, 13, 23, plus 17, 40. 40 divided by how many numbers? 1, 2, 3, 4. Divided by 4 is equal to 10. So the mean of this set of numbers is 10 actually. Okay, 10. Very good. So that's what a mean is. It's a very simple, very basic concept. Okay, now we're going to start with this one. Number 1. Again, you get 2 minutes, and then I will come by and help you out. So 3, 2, 1, let's start. Okay, so this one says in a hardware store, the mean revenue was 4,000 per day over an 8-day period. So you have 4,000 per day over an 8-day period. During this period, if the average daily revenue was 3,600 for the first 6 days, what was the average daily revenue for the last 2 days? Okay, so they tell me for the first 8 days, let's say 8 days, you get the mean of 4,000. So 4,000. Basically, let's do this. If you want to do, you want to get the sum, right, of those for those 8 days. 8 days. What do? You get the sum of those 8 days. You divide it by 8, and that gave you 4,000. So the sum of the 8 days will be the same as 4,000 times 8. Okay, that's the sum of 8 days. The first 8 days. Then what happens? During the period, if the average daily revenue was 3,600 for the first 6 days. So for the first 6 days, what do you get? You have the sum of 6 days divided by 6 is equal to 3,600. That's the same thing as saying this, right? Okay, so the sum of the first 6 days, you get 3,600 times 6. What is the average daily revenue for the last 2 days? So we know something. We know something that we have the first 6 days plus the sum of the next 2 days divided by 8 is equal to 40,000, right? Or 4,000, I'm sorry, 4,000. Okay, so what we're going to do is this. We have the value for this, which is 3,600 times 6 plus 2 days. We don't know. We're going to say 2x. That's what we're looking for. And then that's equal to 4,000 times 8. So there you solve for x. So the first one, so for this one you get something like 36 times 6, you get 6, 3, 6 times 3, 18, 19, 20, 21. So basically you get this, right? 21,000. That's 2x is equal to 8 times 4, that's 32 and 3 zeros. Okay, so 2x would be equal to 32,000 minus 21,600. So basically, 32,000 minus 22, that would be 10 plus 400, 10, 400, like that. Okay? X will be equal to 5,200. D. That's my answer. Okay? Simple, right? Very simple. So now let's go to the next one. This one, number 2. Okay, again, you got 2 minutes, and then we'll be going over this together. Okay, so for the past 6 days, the average, the mean daily production at a factory was 70 units. Okay. If today's production of 90 units raises the average to 75 units per day, what is the value of X? Okay, so you have X days, and the average production was 70. So if you have the sum of those X days divided by the number of those X days is equal to 70. So actually the sum of those X days would be the same as 70 times X. Okay. Today's production rose the average to 75. So there is one more day. So actually you have here the average or the sum of the first X days plus 90. And here on the denominator we have all the number of days, which is X days plus 1 day, right? This is 1 day. So X plus 1, that'll be equal to 75. Now we can just replace this one and have 70x here. So we have all of that in terms of x. So at the end we have 70x plus 90 is equal to 75 multiplied by x plus 1. Okay, so we can easily solve that to get x. Let's do that. So we have 70x plus 90 equal to 75x plus 75. Now we have 5x here and we get 15 here. So x is equal to 3 actually. Okay, x is equal to 3. There we go, 3. Okay, very easy, right? So now let's go to the next concept, the next theory, weighted average. What is the weighted average? When you have, let's say, several sets, and you already are given the mean of those sets, then there's a shortcut to get the average. You don't have to sum them all and divide them all up, okay? So there's a shortcut. Let's see. When different sets contribute with different values, we must use the weighted average. We can find the weighted average in 2 ways. Number 1, adding all the values and dividing by the total number of elements. So basically, this is the usual way to do it. It's longer, or it takes longer. Now, number 2, multiplying the mean of each set by the number of values in that set. That's what we want to do because that's a shortcut, okay? Shortcut. And then dividing by the total number of elements. So, let's see. If we have these 2 sets here, 1, 2, 3, and 4, 8, and 10, we have 2 ways to do this. We can do it without the weighted average, just directly. Total sum, so we say 1 plus 2 plus 3 plus 4 plus 8 plus 10 divided by the number of elements, total number of elements, 3 here, and here is 4, so 7, okay? That's just like we would do, or we would find out the common average, right? The common mean, okay? We are not using a shortcut here. What is a shortcut though? First, we find the mean of the first set. What is the mean of the first set? In this case is 1 plus 2, 3 plus 3, 3 divided by 3, 2, right? So 2 is the mean of the first set. And we multiply that times the number of elements for the first set, which is 1, 2, 3, 3 people, right? Now, we're going to add the mean of the second set multiplied by the number of elements. The number of elements second set is 4. What is the mean of the first set? 4 plus 8 is 12. 22, 32 divided by 4, 8, right? 8 times 4. So that's what you get. And on the bottom, the denominator, you have the total number of elements, which is the same, 7, okay? So this one is going to be shortcut. In this example, it's not that clear, right? But imagine if you had more sets. Let's say you have set number 1, set number 2, and then you have another set which is 5, 13, 8, 12, and then you have another set that is 8, 22, 47. If you add all those numbers, that's a little troublesome, I would say. So on what's even more, now imagine they already give you the means. So they tell the mean here is 2, mean here is 8, mean here is whatever. So if they already give you the means, the shortcut would be much more simple, much more direct, okay? So that's what we want to do. Let's go and practice this. So you have 2 minutes here, and then after 2 minutes, I'll come by and save you. Very good. So if the average, the mean of the assessed values of A cars that's the number, right? Number A of cars is 48,000. So let's say you have a set, right? First set, and you have a number of values, right? That number of values is A. A could be 5 elements, 6 elements, whatever a number of elements you have, it's A. And they tell you that the average of this set is 48,000. Okay? So the sum of A divided by A is equal to 48,000. And then for B, you do the same thing. You have another set. You have B number of elements. They tell you that the average of that is 32,000. So the sum of B divided by B is equal to 32,000. Okay? What is the average of the assessed values A and B houses? Okay, the first thing we want to do is we don't want to work with thousands. So we're just going to get rid of that, okay? It's the same thing for us to get, because we don't have to get the actual number. We just want to know if it's possible for us to give an answer based on this statement, because this one is a data sufficiency. Remember that. So let's see, you have, if we use the weighted average, we have the mean for the first set, 48, times the number of elements in the first set, A, plus the mean in the second set, which is in this case 32, times the number of elements in the second set, which is B. Okay, and in the bottom you have the total number of elements, which is A plus B. That's what we have. Okay, now let's see if we can find out the actual value of A plus B. Here I tell you A plus B, right? What is the average of the assessed values of A plus B? Is 48. You say, oh, nice, because they give you basically this number here. A plus B is 48, so that's 48. Okay, but is there a way for us to get A and B independently? No. Why? Because you have so many possible combinations. It could be that A is 47 and B is 1. It could be that A is 1, B 47. It could be that A is, I don't know, A could be 45 and B 2, and so B, I'm sorry, 3, right? Or 3 and 45. So there are so many combinations, there are no restrictions. They would take different values, and of course different values for A and different values for B would give you different results, okay, because you're multiplying them by different numbers, right? One is 32, the other one is 48. So in this case, that's not enough. Okay, so the first one is not enough. So A is discarded, and so is D, as far as the answer choices from the data sufficiency. Now let's go over to letter B. Let's do it with purple. Okay, A is equal to 3B. They give me kind of a relationship between those two constants. Okay, now what happens in this case? If you have this one, you can start getting replacing here. So you have A is equal to 3B. So this one will actually be 3B, A, right, plus B is equal to 4B. Okay, then you can also replace this one. This A will become 3B. And why is that good? Because you can start, at the end you have something like this. Let me erase up here this info on the button. I'm erasing. Be patient. Okay. So in this case, what we have is this. 48 times 3 times B plus 32B over 4B. That's your answer. Now what happens? We can factorize B here, right, from the numerator. So we remove this B, and then what can we do? We can cancel out B. So you'll be left with only numbers, right? 48 multiplied by 3 plus 32 over 4, and then that's an answer, because those are numbers, right? You can operate them. So B alone is enough. So in this case, B. Okay, pretty simple, right? Very simple. Now we're going to come over a different concept, which is the median. Median questions are usually very easy, okay? What is the median? The median is the number that is halfway in the set. To find the median, the data should be arranged in order, ascending order from the least to the greatest element. So that's the first thing you want to do, is you want to arrange your set in an ascending order. So this one's already arranged in ascending order, so you have A 15, 24 minus 8. Actually, it's not, right? So let me do that, right? You have minus 8, you have minus 6, then what do we have here? Minus 6, minus 8. You have, I think, 0, Okay, and then you have what? 8, 11. 8, 11, and then you have 13, 15, 24. No, 12, 13, 12, 13, 15, 24. So that's what you get in there. Now, how many elements you have here? You have 1, 2, 3, 4, 5, 6, 7, 8, 9. If you have 9 elements in total. 9 elements, right? Now, if you have an odd number of elements, then your median is always going to be one of these numbers, the one that falls in the middle, right? So if you have 9 numbers, the 5th element will be your median. Why? Because you have 4 to the right, 4 to the left, and then 4 to the right, and then 11 will be your median. You see? Okay, that happens when you have an odd number of values. Now, what happens when you have an even number of values? You have to get the median from taking the mean, or getting the mean from the 2 middlemost numbers. So let's say here we have 3, 4, 5, 6. All right, here you have 6 elements. Let's find the median. So you have 6. Let's arrange them first. You have 3, you have 5, you have 8, you have 10, you have 11, you have 12, right? Now, what's in the middle? And you have 2 in the middle. 2 to the left, 2 to the right, and in the middle you have 8 and 10. So what you have to do is you have to get the average, or the mean, from 8 and 10, which is 18 divided by 2, which is equal to 9. And 9 is the median in that case, okay? So if you have an odd number, so if you have an odd number of total elements, your median will be one of those numbers, the one that is in the middle. But if you have an even number of total elements in the set, then your median will be the one that is the average from the 2 middlemost numbers, okay? So now let's go and do this one. This one is an intermediate question from the median, okay? Or for the median, so just be careful with this, okay? Tread lightly. All right, so this one's a nice one. I like this question a lot. It says, what is the median number of dogs assigned per mission for the missions at the Black Ops squad? Okay, for those of you who've played Call of Duty, then you would relate to this one, right? Now, number 1, 35% of the missions at the Black Ops squad have 6 or more dogs assigned to each mission. So they say basically the question is asking you, we don't know how many missions you get. It could be 10, 100, 1,000, okay? But then they're asking you for the median number of dogs. So if we were to arrange the number of dogs per mission, let's say we have here 3 missions have 1 dog. 3 more missions have 3 dogs, right? This is weird. Three. 2 more missions have 4 dogs, and so on, right? So once we arrange all of those values, what number is in the middle? What number is in the middle? That's the thing, okay? So we don't know how many elements we have here, and we don't know the number of elements. We don't know the number of projects, in this case, or missions, okay? 35% of the missions at the Black Ops squad have 6 or more. So 6 or more is already giving me the upper limit, okay? So which means they say 35% here of this, let's say this whole bar is 100, right, percent. So the top 35% have 6 or more. It could be 6, 7, 8, whatever, or higher up, but 35 have 6 or more. We want to get the 50th percentile. That's the one that is in the middle, right? So if they tell you the top 35 have 6 or more, that means that this top 35 starts where? In 65%. That's the top 35, okay? That's not enough because it doesn't let me know what's in the middle, right? In the middle could be, we know it's less than 6. It could be 5, it could be 4, 3, 2, 1, but we don't know how many. Okay, number 2, let me choose green here. 25% of missions have 4 or fewer. Okay, so the bottom 25% here, which is percentile up to percentile 25, have 4 or fewer. Okay, if that's true, and if I ignore the first statement, then I know that to the right, so the 50th percentile is greater than 4, but I don't know the exact number though. It could be 5, 6, 7, whatever. Now, if we join these two, so each one alone is not, right? But if we combine these two data, what we can get is that the top 25, the bottom 25 percentile is 4 or less, up to 4, right? Up to 4. The top 35, which starts percentile 65 above, right, is 6 or more, so it's at least 6. So what should be in the middle? It cannot be 4, it cannot be 6, it cannot be less than 4, it cannot be greater than 6, so it's got to be 5, right? In that way, we know that all the values that are in the middle, that fall in the middle between percentile 25 and percentile 65, are value of 5 each, okay? So with C, we can answer this question. Again, I know you're loving this video. I know you like it a lot, so show some love. We want to know how much you truly love this video so we can keep on making more of them, okay? So leave a comment. That's what I want you to do right now. Don't do anything else. Just go down there and leave a comment. And also share this video with your friends, okay? So let's go now to the next chapter. So now chapter number 5. Chapter number 5, we're going to talk about maybe, perhaps the most important section or the most important chapter here for the whole quant course, geometry, okay? And this is also the biggest difference between the GMAT, for example, and the executive assessment, right? For those of you planning to take the executive assessment, just go and watch this video that will explain all the differences between the GMAT and the EA. Before getting to chapter number 5, don't forget to subscribe to the channel, click on the like button, click on the notification bell, and you can also send some money our way. If you truly appreciate us, you can click on that super thanks button. All right, perfect. So now we're going to start with geometry, okay? Geometry is a big lesson, the biggest one actually, so we're going to stay here for a long time, okay? So the first thing we're going to say is coordinate geometry, actually the coordinate plane. Here you have it, right? You've gone over this in middle school, high school, so you should be already acquainted with it. Now, you have 4 quadrants in the coordinate plane, and quadrant number 1, you have your position actually here, right? Your X and Y, right? X shows you how you're going to move in the X axis, here the horizontal line, and Y shows you how you are to move on the vertical Y axis, okay? So it should be fairly easy. Quadrant number 1, actually, you have positive X and positive Y, right? On quadrant number 2, you have a negative X and a positive Y. Quadrant number 3, you have a negative X and negative Y. And on quadrant number 4, you have a positive X and a negative Y, okay? So this is easy, and now we're going to learn how to draw a line because they're going to mix a lot of lines here with this coordinate plane. So what is a line? It is a line, right? You already know that. Line is infinite actually, so it goes to infinity, right? But the equation will be given by something like this. You have y equals to mx plus b, right? An equation with two variables can be represented in the xy coordinate plane as a line, right? It follows the following general formula. So whenever you get something that you believe that has two variables and you believe that you want to put it in a line format, this is the equation. Actually, this is the shape, the format you have to give it. So y equals something, okay? Now, the constant here that is accompanying x is called m. That's going to be the slope, okay? The slope is the inclination of the line, okay? So if you have a negative slope, the line will go this way, kind of like that. If you have a positive slope, the line will go this way, okay? Now, this constant here, b, m and b are constants, okay? B is the y-intercept. Basically, that tells you the number, the altitude at which this line cuts through, intercepts the y-axis, the vertical axis. Okay, for example, if this is, let's say this is y2, and here's where the line cuts it, b would get the value of 2. So something like that. You see, easy, right? Now, y and x are variables, which means that there are tons of different combinations that would give you a result. Okay, so this may be 1 point, x something, y something, this one may be another point, this one another point. So there are tons. All this line is made out of points, different values for y and x, different combinations that will comply with that equation. Okay, so we already know the first thing you do when you want to draw a line, you want to get this format. Okay, m is the slope and b the y-intercept. This is only true if y is isolated. That's why you want to put it in this format. Okay, so now how do you know that you can get a full line? Okay, a line is completely defined by two things. Number one, 2 points. Number two, 1 point and a slope. So if they give you 2 points, for example, they tell you we have point 3, negative 2, and we have point 8, 4, and the line crosses those 2 points, right? With that, you can get the equation of the line. You can get to know the line, so you can draw it. Okay. Now, if you have 1 point, let's say you only have 3 and negative 2. Okay. But they also give you the slope, right? They tell you that the value of m is, I don't know, positive 1/3. So with that, you can also get to know the whole line and the other components. Okay, so you can draw it. So those are the two data sufficiency components that you need in order to get to know the equation of a line. So here, let's practice with this one. Again, you have 2 minutes, and then I'll come by and show you the way. Okay, so let's read this. In the xy plane, line A passes through the point 2, comma 1, and line B passes through the point 2, comma negative 1. Are the lines A and B perpendicular to each other? So perpendicular, when they tell me perpendicular, it means that those lines, something like that, right? They form a 90-degree angle, right? So also you can tell if two lines are perpendicular because the product of their slope, let's say line A has slope MA, right? And line B has slope MB, right? Once you multiply those two slopes, you should get what? -1, okay? Which means those two slopes will be reciprocal, negative reciprocals. If A has a slope that is 1/3, B has to have a slope of -3 in order for you to get -1. Okay, that's always true when you are dealing with perpendicular lines. But in order for us to know if they're perpendicular, first we have to know those lines. So we have to know the equations of those lines. We have to be able to draw them. So that's what they're asking us. Okay, so line A, we already have 1 point for each. Okay, for A we have this point 2, comma 1. For B we have this point 2, comma -1. Okay, so if we're going to try to draw it, this is the coordinate plane. This is 2, let's say 2, 1, right? This is the first point for line A. And this is a 2, -1 here. This is the first point for line B. Okay, we need another point though. Now let's go with the first data. Line A and B intersect in the point 2, comma -1. So, which means 2, comma -1 is also a point for A. Because, so we already know line A. Line A goes something like this. Okay, but we don't know that's line A. But we don't know anything about line B though. Line B could be, for example, let me show you here. Could go like that, could go like that, could go like that. We don't know. We know it crosses this point 2, comma -1, but we don't know in which direction. We don't know the slope because we don't have any other point either. Okay. Now, so the first one alone is not enough. Number 2, line A intersects the x-axis at the point 2, comma 0. So that's another point for, let's say, if we are not evaluating the first one, we're just evaluating the second one, we have a second point for line A, right? 2, which is this point here. Okay, if we combine them both, that's not enough, right? Because they tell us nothing about line B. Now, if we combine those two pieces of data, we have 3 points for line A. That's more than enough. Actually, 2 were enough. If we have 2 points, we can get to know the line, right? We didn't need 3 to begin with. And but we don't know B though, because B, we only have 1 point. So for us, answer is going to be E. Why? Because we need 1 more point for B, or the slope for B, in order for us to know how line B is. Okay, so that's fairly easy. Let's now go, this is an easy question actually, right? So let's now go to the second question. Okay, this one is a little bit more interesting. Let's see this one. You have 2 minutes and then I'll come back and show you the right way to do it. Okay, here, number 2, in the rectangular coordinate system above, this one here, the shaded region, this region, is bounded by straight lines. Yep, it's bounded, right? So it's enclosed by 4 lines, actually. Which of the following is not an equation of one of the boundary lines? So basically, you have 4 lines. You have this one here, vertical, 2 vertical lines, one that goes diagonally with a negative slope, and the horizontal line. So which one is not? Okay, x is equal to 0. What is x is equal to 0? Why do you think x is equal to 0 is actually the y-intercept? That's x is equal to 0, okay? So the y-intercept would be, actually when you have x is equal to 3, for example, that means that's a vertical line. This is my coordinate plane, and you have something like here 3, and this would be x is equal to 3. So basically a vertical line that crosses x at 3. Okay, now if you have y is equal to, let me change colors, y is equal to 0, that means that's the horizontal x-axis. So this one here, okay, that's y is equal to 0. If you have, for example, y is equal to 2, that means you go to y, this is a y axis, you go to 2, and that's a horizontal line that crosses y at 2. Okay, so those 2 lines are in this graph, are enclosing that shaded area, right? Because you see, this is the y-axis, and this one is the x-axis. So those 2, this one and this one, are enclosing that area. Okay, so those are not going to be the answer. They are asking us what is not, or the equation that is not in here. Okay, x is equal to 2 is this one here, vertical line crossing x at 2. So that one is x equal to 2. So that one's also in there. So the only thing we're missing here right now would be this line that goes from y-intercept 2, right, goes to x4 with a negative slope. That's the only thing we're missing so far. So now let's see. Let me change colors. This one is x is equal to y. Okay, for those of you, if you want to know, x is equal to y is a very simple thing to graph, to represent. Actually, if this is my coordinate plane, x is equal to y will be something like this. Okay, something we'll cut the first quadrant in half, okay, with a 45-degree angle. So we don't have that here. We already know that's the answer because it is not one of these lines. But just for the sake of it, let's continue and let's try to analyze this equation. First thing we want to do in order to analyze what kind of line it is that we want to put it in the format of the line, right? So y equals mx plus b. So in this case, we're going to say 2y is equal to negative x plus 4, which is the same thing as y is equal to negative 1/2 x plus 2. And that's this line here, right? How do we know? We have 2, which is here y-intercept. It's got a negative slope. And actually the slope would be something like rise over run, right? So basically, when you have a slope, you're saying how many values it goes up or down and how many values it goes to the right. So it says for each square it goes down, it goes 2 to the right. So here we go 2 to the right, here we go 1 value down, 2 to the right, and we know that's a slope because it crosses this that's inclination of the line, right? 1 down, 2 to the right. So yeah, that's the line, so that's not going to be the answer. Answer D here. Very easy. Okay, now let's go to the next one. Okay, let's do this one. This one's a little bit more challenging, but it's an intermediate question. It's not a hard one. Okay, so take your time, take 2 minutes at most. Okay, and then I'll show you the answer. Okay, so they tell us in the XY coordinate system, if the coordinate pair AB and A plus 9, B plus K are 2 points on the line defined by the equation, this one, then K is what? Okay, we don't need to draw the line here, so we don't actually need to get this one into the Y format. Y is equal mx plus b. But let's just, because of we are accustomed to do it, let's do it. Okay, so here we have 3y is equal to x plus 7. Y is equal to 1/3 x plus 7/3. That would be what we have. Okay, now in this coordinate pairs, here A is taking the place of x, B is taking the place of y. In the other one, A plus 9 is taking the place of x, B plus K will be taking the place of y. Okay, now let's see, let's start replacing things, because we want to get to the value of what? The value of K, right? We want to get to K. All right, so let's start. First of all, would be if we replace this pair, this coordinate pair, the first one would be here, B is equal to 1/3 A plus 7/3. Okay, and then this equation should also be true for what? For the other pair, right? Because those are 2 points in the same line, so this line represents the values for all the points that are in that line. Okay, so let's go with this one. It would be y would be b plus k is equal to what? Equal to x, which is 1/3, and then a plus 9 plus 7/3. Basically, that's what we have. Okay, so how are you liking this? That's really neat, right? And now what we're gonna do is, we know that this is b, right? Because we have b equals something, so we're gonna replace this one into this one here, this b. Okay, so now what we're gonna do is, let me change colors to green here. 1/3 a, which is plus 7/3. That's b, this b here. We've just replaced that. Plus k is equal to 1/3 a plus 9/3 plus 3 plus 7/3. Okay, so we have just replaced b, substituted b here. What we do is, these ones get cancelled out, this 7/3 gets cancelled out, and we have k is equal to 3. That's it. 3. C, that's my answer. Fairly easy. Okay, so basically we're using substitution in this case, and we know that if you have a line, that equation is true. I mean, the constants, which are in this case m, right? M and b are true for both of those lines, or I'm sorry, for both of those points, all right? Because those two are points on the same line, so the same equation applies to them. Very good. So that one was fairly easy. Now let's go here to another theory about lines and angles. Okay, so here we have some very easy theory about lines. And angles. First, when you have two lines crossing like that, you get opposite angles that are the same, right? So these angles will be the same, the opposite ones, and these angles will be the same. So here you have this two, here you have this one. Okay, of course, when you have a flat line like that, the angle is 180, right? That's the opening angle. And now when you have two parallel lines, these two must be parallel here, which means the distance between them is the slope is the same. Slope is equal. That's what it means to be parallel. So they are never going to touch. Once you prolong them, once you project them into infinity, they never touch. Okay, unless they're bending time and space, something like that, right? But if you just draw them with the same slope, they will never touch. So once you have that, two lines that are parallel, and then you have one line crossing both those two, right? What happens is you get congruent angles. Okay, so you get a repetition of the angles on both of them. So if this one is here alpha, right? This one is alpha here, and we know the opposite is going to be alpha. So the other line, we're creating the same structures of angles. So those two are going to be alpha also. And the same way with the other one, with beta, right? Beta, 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 beta. Okay. So that's what we have, beta and alpha. All right. Now, line segment AB, when they say segment, basically they're saying that they are taking one part of a line, because the line is infinite. All right. Now a segment is not infinite, and a segment is defined by 2 points. So basically it's this segment here, which is one little piece of the whole line. Here we have the also graphs for perpendicular lines. So we already talked about perpendicular lines, right? In one of the exercises, we mentioned that they form a 90-degree angle and that their slopes, when you multiply them, the product should be -1, right? And this is the graph in order to show that something is perpendicular. Sometimes they're going to use that. Most of the time they won't, but sometimes they might use it. So it'll be better for you to kind of learn that anyways. For parallel lines, you have this this graph here, okay? So see them as emojis, something. Okay, now we go here to this very easy, very simple exercise about angles. So you have 2 minutes. I wouldn't think you need those 2 minutes. Maybe 1 minute should be more than enough, but then you have 2 minutes, and after that I'll show you the right way to do it. Okay, so for this, we know first and foremost that because of our theory of angles, opposite angles are the same. So 4x is the same as y plus 22. We also know that 4x plus 6x is equal to 180 because they form a flat line, right? So actually 10x is equal to 180. X is equal to 18. Once we have x is equal to 18, we can get the value for 4x. 4 times 18 is 40, times plus 32, 72 is equal to y plus 22, and we get the value for y, which is equal to 50. Very, extremely easy, okay? These are very easy questions we're going through right now, okay? So that's number 4, okay? E. It should take you around 1 minute at most. Okay, so these questions that are easy, they are helpful for you to save time. You shouldn't spend all the time here because you're gonna, believe me, you're gonna need that time, that extra time to solve hard questions. Now this one's also easy. So let's do this. Number 5. You have 2 minutes. 3, 2, 1. Let's go. So it says in the figure above, if x over x plus y is equal to 3 over 12, then x is what? Okay, let's try to get x, all right? The first thing we're going to do is we're going to cross multiply 12x is equal to 3x plus 3y, right? From here we can get one equation, right? X plus y is equal to 180. All right, so we can replace, we can say x is equal to 180 minus y, okay? So here we have, we just subtract 3x, so actually it's 9x, right? It's equal to 3y, and y is actually, let's substitute 180 minus, no, actually we want to substitute x in this case, right? So because they asked us for x, so let's just here 3y, we are going to substitute y here. Y is equal to 180 minus x, the same thing. So here we substitute 180 minus x. Okay, so 9x is equal to 3 times 180, that's 300, and then 240, which is the same thing as saying 540, minus 3x. Okay, so this is 12x is equal to 540. X is equal to 540 divided by 12. Actually, if we get, how much is 540 divided by 12? Both of them can be divided by 6. So if we divide this by 6, this one becomes a 2 and this one becomes a 90. X is equal to 45. You see? So that's pretty simple also. 2x is equal to 90, x is equal to 45. Okay, so this one just, I mean, the operation is kind of easy. The theory is also very easy. All right? So don't forget to give us a like if you're enjoying this video. Also leave us a comment below. Okay? Show your love. So now we're going to enter the realm of quadrilaterals. Okay? All quadrilaterals have 4 sides and 4 interior angles. The measures of interior angles add up to 360. So that's a very important and very clever thing to know. Okay? All interior angles of any 4-sided geometrical shape, any quadrilateral, will add up to 360 at all times. Okay? So we have the 2 main types of quadrilaterals, the rectangle and the square. The square is a type of rectangle. So actually, if they tell you there is a rectangle, chances are that that rectangle actually is a square. Okay? So here the rectangle, you have the area A times B, which is A is one of the sides, right? It's called the width, and B would be the length. So you multiply width times length and you get the whole area. What are the characteristics of a rectangle? All the angles are right? All the angles are right. The diagonals are the same, right? Once you have the diagonals, they are both the same size, the same length. The diagonals bisect. Yeah, bisect meaning that they cut each other in the midpoint, right? So this point here is the midpoint of the diagonal, the first one, and the second diagonal also. All sides are parallel. Yes, all sides are parallel and perpendicular, right? So the sides, the length are parallel to each other, and the widths are parallel to each other, and then the width is perpendicular to the length. Okay, so those are the characteristics of a rectangle. Now, what about the characteristics of a square? What makes a square special? All sides are the same. Yeah, that's a difference between the rectangle and the square, right? That in the square, the sides are the same. The 4 of them are the same. So there is no width and length. There is just one side. Okay, and the other ones are the same, actually. All the characteristics of the rectangle, just that additional feature, the sides being the same. Now, for the rectangle, you have this formula for the diagonal. Actually, that's just the Pythagoras theorem. Okay, so basically, you get the width, you get the length. Those are basically the legs of the right triangle, and then the diagonal will be the hypotenuse, right? So you don't need to memorize that because I mean it's fairly easy to see that we are applying the Pythagoras theorem. Now for the square, you have one shortcut, which is side square root of 2. Okay, we're gonna see that later where it comes from when we see triangles. It's actually a common triangle that is side square root of 2, but it's better for you just to memorize it. Okay, so the diagonal for a square is side square root of 2. Because you might be tempted to do the Pythagoras theorem here, and that would just be a waste of time if you say s squared plus s squared is equal to diagonal square, and then you'll find out that it gives you the same thing. Okay, so it's not important here. So just go and memorize this formula for the diagonal. Okay, so here let's do some problems with squares and quadrilaterals. Okay, you get 2 minutes to do this, and then I'll come by and save you. So 2 minutes. All right, so here it says if a square TV, all TV, right? There were used to be square TVs. Square TV has a 20-inch diagonal. 20-inch diagonal. What is the approximate perimeter of the TV in inches? So what we can do here is that we know that this one's sides, right? You have 4 sides, so actually they're asking you for the perimeter, 4 S's. Notice the word approximate, so we don't need to give the exact answer, something that is close enough. Okay, the numbers vary among themselves fairly by a big number, right? By 20, which is a lot. So here we have the diagonal of a square is side square root of 2. It's equal to 20. So what is the side equal to? Side is equal to 20 divided by the square root of 2. Now what we want to do is 4 sides is equal to 4 times 20 divided by the square root of 2. Square root of 2, and we should know this, is kind of 1.4. So we are going to round it up to 1.5. Let's see if that works. So this becomes 1.5. If we multiply it times 10, it becomes 15, right? Let's multiply this times 10, it becomes, what can we do here? We can just take 5, becomes 3. We take 5, this one becomes 2, right? So we will get 8 times 20, which is 160, divided by 3. And that gives us, what? A little over 50, right? 50 something, 53 or something like that. So that's more towards 60 than towards 40. Now, we did this one with 1.5, which made the denominator greater, which means that if we would have used 1.4, which is more like a square root of 2, the number would have been larger. So it would be 55 or something, or 56 maybe. Okay, so 60 is closer. 60 is closer to the answer here, definitely. Okay, so that's how we get our approximation. We were able to do this approximation because the question actually states that, right? The approximate perimeter. They're not asking you for the exact number. Okay, easy, right? Now let's move on to the next one, number 7. You get 2 minutes starting right now. Okay, so here let's read that question. The front of a 6-foot by 8-foot building model at Liberty's exposition has a golden rectangular trim. Okay, so this is not golden actually, but it's represented by this shaded thing, right? As indicated by the shading in the figure above. So the whole blue thing is a golden rectangular trim. Okay. What else? If the trim is uniformly 1 foot wide, so this trim uniformly, so it means in any position you get it, it's always going to be 1 foot. What fraction of building's front surface is covered by the trim? Okay, the fraction. So basically, if it's a fraction, here you have the total surface, and here you have the blue. Okay. Now, getting the the area of the blue trim or the golden trim is a little difficult. So what we're gonna do is we're gonna get it through the complement. Total. Here we're gonna say total minus the white portions, right? Because if you get the total minus the white portions, that gives you the blue. So I believe that's going to be a faster way to do it. Okay. What is the total? 6 times 8, 48, right? What is, so here we have 48 minus what? Minus the white. What is the white? Okay. So let's just, this is 1 foot, so 8, right? Actually becomes 1 less, 7, 6, 5, 4. So it'll be 4, right? So the spaces of white would make up 4, length of 4, because you are reducing or you are subtracting 4 spaces of 1 foot from the trim. And here in 6 it becomes minus 2, right? Because you have 2 1 foot trim, so it becomes 4 also. 4 times 4 is 16. Okay, so you get 48 minus 16 of 48. 48 minus 16 would be equal to actually 32, right? 32 over 48. If you divide this by 4, you get 8. Here you get 12, right? 12. And if you divide this by 4 again, you get 2 and you get 3. So 2/3 E. That's the answer. Easy, right? So it's just a matter of always trying to find the easiest route. Okay, the easiest route. So here getting the blue one was difficult, so you go with total minus the white one, and it's the same thing as getting blue, right? So it's way easier. Okay, so here we come over the theory of triangles. Okay, a triangle, one thing that is not here that I have to tell you is that if you add the interior angles of any triangle, or disregarding its shape, it will always add up to 180 degrees. Okay, now here they give you the formula for the area of the triangle. The area is the same as base times height divided by 2, or some people learn it as base times height times 1/2, which is the same thing. Okay, so you multiply the base by the height and you then divide it by 2. Now any side of a triangle can be used as a base, right? It could be, it could be that this is the base, whatever, right? And the corresponding height is the perpendicular line segment from the opposite vertex to the base. So if I choose this 15 as my height, then my height will as the base, then my height will have to be a perpendicular line going to the other vertex. Perpendicular meaning that it has to create a 90-degree angle. Okay, that's my height. Now, with this right triangle, a right triangle is one that already has a 90-degree angle. It will be easy, right? Because one of the legs will be the height. Now, what happens with this triangle here? Okay, if you get a perpendicular line, this is your base, let's say, right? If you create a perpendicular line from the base, you never get to the opposite vertex, right? Because the vertex is in a way that it's not reachable. So what you have to do is you have to prolong your line up to the place where you can actually make a perpendicular line to the opposite vertex. Okay, in that way you get the height. Okay, in all cases, in this one's 6 height times base 15 divided by 2 is equal to 45. Okay, so that's the area of a triangle. So now let's do one exercise, one intermediate, kind of easy exercise regarding the area of a triangle. You get 2 minutes. Okay, so here we say in the rectangular coordinate system above, if OP is less than PQ, so you have, they don't give you numbers, right? So OP here, OP, we know that that's smaller, shorter than PQ. That's one thing we know, right? So OP shorter than PQ. Is the area of the region OPQ? OPQ, so that triangle greater than 24. Let's see. The coordinates of point P are 4, 6. P. So here is actually 4, 6. So this one, x is equal to 4 and y will be equal to 6. P is 4, 6. What does it mean? It means that we know that the height, right? The height is 6. And we also know for the, let's cut this triangle in half. For the left side, we have the height, and we also have the base. Actually, base is 4, height is 6. Okay, so we know this whole piece here on the left is 6 times 4 divided by 2. That's the area of that thing on the left. That's equal to 12. Okay, now what do we know from that? We know that before they had told us that OP is less than PQ, which means PQ, and they're also here on the x-axis, right? So PQ must be greater, which means that the difference between O and 4 is less than the difference between 4 and Q. So here the base for this triangle on the right will be greater than 4. Okay, if you have a base that is greater than 4 multiplied by 6, you are gonna get definitely an area that is greater than 12. Okay, so with that we can answer, we can say yes, the area of the whole triangle is gonna be greater than 24, because we know that the side on the left is 12 and the side on the right is more than 12, the areas. Okay, so that's that answers. So far, if we have our data sufficiency answer choices, D and E, we can eliminate E, we can eliminate C also, and we can eliminate B. It could be A or D. Okay, now let's go to the next data. So, or datum, as we would say, right? So here we say, this color, yeah. Coordinates of point Q are 9 and 0. So this one is 9. Okay. And this one's 0. We already know 0 for the center, right? Now, what's the matter with that? It doesn't give us what? The height, right? No height. So if we don't have the height, there is no way for us to get the value of P, right? We need the height, because that's necessary for us to get the area. So in this case, no. So the answer here would be A. Okay? Simple. You see? Very simple. And now we're going to talk about common triangles. And this is maybe the most important slide in the whole geometry lesson. Okay? So there are 3 types of common right triangles. This only applies for right triangles. What is a right triangle? Again, a triangle that has one of the angles 90 degrees, right? So there are 3 types of common triangles. Basically, this is going to help you out just to get the information regarding the angles and regarding the sides of those triangles pretty quickly without doing any operation at all, just memorizing different patterns. For example, the first common triangle says if you have 2 legs, we call these legs, right? Legs. You have 2 legs and you have the hypotenuse, right? Those 2 legs have the same size, right? So you have K and K, K and K. Then the hypotenuse would be in the size of K, that constant, times square root of 2. So if I have a triangle that says 5 and 5, I don't need to do Pythagoras here. I just know that by theory, this hypotenuse is 5 square root of 2. You see? The same, and you also know 2 more things, that the interior angles are 45 and 45, 90. So these 2 angles are 45, both of them, and then your right angle is 90. Okay? Now, if we have, for example, that's very useful if we see something like this, right? Sometimes they could give us something like you have your right triangle, 90 degree, one of the angles is 45, and this one is this size, the length of the one of the legs is 6. What do we know? First of all, we know that the other angle is 45, right? Because 90 plus 45 plus the other angle, they have to add up to 180. So the only possible value for the other angle is 45. So we know that this is a 45, 45, 90 degree triangle. So we already know how the lengths of the legs and the hypotenuse are going to correlate. So the other length must be 6 also, and this hypotenuse must be 6 square root of 2. So you see, you don't have to operate at all if you memorize the patterns and the relationships between these angles and these lengths of the sides and the hypotenuse. Very good. So the second common triangle will be this one. Actually, we don't care about these angles. What we care about is the relationship between the legs and the hypotenuse. So they say 3, 4, 5. 3K, 4K, and 5K. So actually they go in the relationship of 3, 4, 5. So if we have, let's say, a triangle, right, which we have here 6, here we have 8, we already know by theory that the hypotenuse must be in a relationship of 5. So this one's 3 times 2, this one's 4 times 2, this one should be 5 times 2, which is 10. You see? The same thing if we have something like here, I don't know, 20, right? This one should be 16, right? 16, and this one should be what? What do you think? 12, right? 12, 16, and 20. Okay, so that's a triangle. We don't need to operate anything if we know our relationships. And the last common triangle will be something like this: 30, 60, 90. All right, it goes in the relationship of k square root of 3, and 2k. And so that's the same thing. You apply those. You just. So that's the same thing, and you can get the other information just by looking at that triangle. Okay, so those are common triangles, and you have to memorize them. They are very important, and the GMAT likes to play a lot with them. Okay, so memorize these triangles as soon as you can. And then, of course, we have the Pythagorean theorem. Okay, so the Pythagorean theorem tells you this: once you have any right triangle, right, you have two legs and you have one hypotenuse. They tell you will get the hypotenuse if you add the square of each of the legs. So a squared plus b squared is equal to the hypotenuse square. And then after you get the hypotenuse, then you have to take the square root of it to get c, right? But that's a relationship. Okay, and this is also very useful for other quadrilaterals for you to get that diagonal, right? In case you have a 90-degree angle. So those are common triangles. This is a very important part of the theory. Now let's go to the practice here. All right, so it says in the figure above, segments MZ. MZ is this one here, MZ. And LW, let me change colors here. LW is this one here. Okay, wasn't too good, but it was like that. All right, and LW and MZ represent two positions of the same pole leaning against the side. WO of a column. WO is this black side here, right? The vertical side. Okay, here it says the same pole. So actually, what we already know is that MZ is the same as LW. They're the same length, right? Because they're the same pole. Now, the length of MO here. Now we go to the bottom. MO, the length of this MO is how much greater than the length of LO. LO would be something here, right? LO. So basically we want to get MO, not LO, right? We don't want to get the exact number, but we want to know if it's possible from this data to get the difference. Okay, we also have to notice the degrees. Okay, so we already know several things about this purple triangle. We know this is a right angle. We know it's 40, so we know it's a 45, 45, 90 degree triangle. We also know several things about this green triangle, right? We know it's a right triangle also, 60, 30, 30, 60, and 90. Okay, so we already know. So for the green one, we have 30, 60, and 90. 30, 60, and 90. And we know the relationships just from studying the common triangles. They go in the relationship of K, right? 3K, 4K, 5K. Now for the purple triangle, which is 45, 45, 90, they go in the relationship of K, K, K square root of 2. So if we know one of the sides, we already can get all the other ones. Okay. The length of MO is 2 meters. So they give me MO. They're giving me K, right? K is MO. We already have, so we can, with that, we can get the hypotenuse. And the hypotenuse would be MZ, and MC is the same as LW. So we would also get LW. If we have the hypotenuse LW, we can get the other side, right? 5K, and we can get K. So we can get 3K also. So we would know MO, yes, because they give us MO. Will we know LO also, because from the hypotenuse of LW we can get 3K, which is LO. So we can get those two values. That's enough. Okay, so that's enough. That's good. Just by playing with these common triangles. Now, number 2. The length of WO. WO, okay. WO would be this length for the green triangle, this one here. All right, is 5 meters. All right, that helps me. Why? Because it's a common triangle that's 4K, right? With that, I can get 3K, what 3K is, and what 5K is. So with that, I would have LO already, yes. And from that, we will have also the size of length of LW. We have LW, we also have MZ, because MC is the same thing as LW. And if we have MZ, which is actually the hypotenuse of the purple triangle, we also get the legs, one of which is MO. Okay, so we also have MO and LO, so that's okay too. So in this case, D, both of them independently can give you the answer. Okay, pretty simple if you know your common triangles. Now let's go here to number 10. This one is a little harder. Let's just try it out. All right, so they tell you bro and fool. All right, fool are at the northeastern corner of a cornfield. Northeastern, okay, which is a rectangle with measure 60 and 45 degrees. 45 yards wide, I'm sorry. So let's see, there are two options, right? That rectangle goes something like this. So it's here 45 and here 60, or that rectangle goes something like this, right? And here we have 60 and here we have 45. Anyways, bro and fool, those two guys, the fool and bro, are here in the northeastern corner. Okay, let's see if the story will tell us which orientation this rectangle is, this rectangle has. Okay, bro walks a straight line to the southwestern corner. Okay, so what bro does, let's draw here bro. Here's bro. Right, that's bro. Bro. Okay, what bro does, he walks a straight line to the southwest. This is the southwestern corner. Right, he walks like that. Okay. Well, fool, what does the fool do? The fool will do this. Here we have green. Okay, let's show this. This is fool. Fool. Okay. The fool do this. He prefers to walk 50 yards south. So we already know something. If fool prefers to walk 50 yards south, it means he's getting out of this this terrain, right? So it's not this orientation. That orientation is impossible. It's just this orientation here. So he walks 50 yards south up to here, let's say. And then a straight line to the southwestern corner. So then fool walks here. Okay, so that's what he walks. It's a different path than, so he takes longer, right? What a fool. Okay, what is the difference in the distance traveled by these two characters? All right, so we know that fool walked 50, right? 50 down, and then we have to get actually the hypotenuse here of that triangle. While bro walked all the way. So fool, let's first get fool, okay? Fool walks 50, and then what do we have here? We have 60, so we have actually 10 remaining. So we have a right triangle, like it goes 10, 45, and here x. We have to get x. Okay, so we use Pythagoras. We have 100 plus 45 squared. What is 45 squared? That's equal to 45 squared. 45 times 45, 25. 20, 22. 45 the same thing. Here we have 20. And 4, 16, 18, right? So it goes with 5, 2, 2. 20, 25. It's equal to x. Now, what is 20, 25 plus 100 is 2125, right? 2125 is equal to x squared, actually. All right, so what's the value for x squared? That's a question. Let's try to get that value, okay? So actually, it doesn't give you an actual number. We know these are pretty spaced up, so let's just approximate it, right? So let's just approximate it, okay? So we're gonna do 46 times 46, or maybe 47 times 47. Let's try which one is closer. 46 times 46 is 36. 6 times 4, 24, 27. 4 times 6 is the same thing, 24. 4 times 4, 16 is 18. Okay, so 6, 11, 9, 11. Here, 21, 16. I think that's pretty close. Okay, let's try 47, 47, 9. Here, 49. And here we have 7 times 4, which is 28. 32. 4 times 7 is 28. 16, 17, 18. Here we get 9, 10, 9, 4, 12. 2. That's too much. Okay, so let's say that's kind of 46. Kind of 46. So x is kind of 46 here. Not quite, but it's kind of 40. So this fool, actually, he walked 50 plus 46. Kind of like a little more than 40, 46 point something. Okay, so this fool traveled what, 96 yards. Okay, and that's what fool did. Now, what about bro? What about bro? What do we do with bro? We just get straight hypotenuse, right? We just apply Pythagoras over there. But then we notice something even more special, even more astonishing, that we have 45, 60. And is that gonna give us something? Let's say, can we get 3, 4, 5 out of there? if we divide this, let's say by 15, you get 3 times 45 is 3 times 15, right? 60 is 4 times 15. And this one, the hypotenuse, would be what? 5 times 15, which is equal to 75. Okay, so we don't need to do any operation with Pythagoras because we already know that's a common triangle. So bro walked 75 yards. So the difference here is almost 20, right? A little more than 20, so 20 here. Okay, so that's the thing with this one. That's the thing with this one. It's kind of 20. Okay, so this one was maybe an intermediate, maybe a little harder. All right, but just playing with common triangles because that's going to allow you to save some time and then to get a good approximation. So now we go to the theory of circles. Okay, circles. What are circles? Well, this is a circle. Let me introduce the circle to you. Okay, this circle, we have a center, the point in the middle. We have a radius. Here, radius is a line that touches any of the points in the circle from the center, right? We have the diameter. The diameter is basically a line that cuts the circle, that goes from two opposite sides of a circle, going through the midpoint, through the center. Okay, that's the diameter. Diameter is equal to 2 radius, right? 2 radius. Okay, so ST in this case would be a diameter. Now, what is a chord? PQ will be a chord. A chord is any line that touches 2 points of a circle but doesn't pass through the center, right? Because if it passed through the center, it would be a diameter. Okay, but that's a chord. Okay, then the circumference and the area are given by this formula. So the circumference would be 2r pi. Okay, pi is 3.14 or something like that. So 2r is the same thing as saying d, diameter. Diameter times pi, or twice the radius, which is the same thing as the diameter, times pi. That's the circumference, which is basically the perimeter of the whole circle, right? And the area is given by r square root, r square, and pi. And the area is given by r squared times pi. Okay, now when you have a circle like this and you are getting a line that is tangent to a circle, you will create a perpendicular line with the radius, right? So it's perpendicular. So basically, if there is a tangent line that touches one point of a circle, you will create a 90-degree angle with the radius. So that's everything you need to know about the circle. Let's now go and do this easy question, 11. All right, it says the figure above shows a gigantic circular cake with its center at O, this is center, surrounded by a circular chocolate trim that is 3 feet wide. Okay, 3 feet wide. What is the area of the chocolate trim in square feet? Now, something I have to tell you, very important. Never trust, do not trust the graphs, right? These graphs on the GMAT are not drawn to scale, okay? Because you might say, oh, okay, this one is 6 feet and this one looks like 2, not 3, right? Yeah, but it doesn't matter, okay? That's just a graph. It is not drawn to scale. So it's you cannot just measure from those graphs. Okay, geometrical graphs are like that. Now, if they give you something like bars, right, or line charts, like something like that, those will be drawn to scale. So those are okay. You can trust your eyes in that department. But in this case, geometrical shapes, they are not drawn to scale. Okay, so they tell you have the center O, the circular trim, this black trim is 3. And what is the area of the chocolate trim? So if you want to get the area of the black, what do? You get the area of the total minus the white. That's the easiest way to approach this. What is the total? 6 plus 3. So the whole radius of the total thing would be 9, right? So you have radius 9 square pi. Minus what? Minus the white. 6 square pi. So that's what you have. 81 pi minus 36 pi. And that's equal to what? And what is that equal to? That's equal to 51 minus 6, which is 45 pi. Okay, 45 pi. Letter C is your answer. Pretty simple, right? Pretty simple. A caveman can do it. Okay. Now, if you're liking this video and you want more content like this, you can follow us in our social media, Facebook, Instagram, and TikTok. So also, if you're looking to increase your score, your GMAT score, and you are looking for high quality tutoring, just go to our website, okay, and check out our services. The link is in the description below. So here we have different question, number 12. So let's do this one. 3, 2, 1, let's go. All right, so it says, what is the circumference of the circle above with center O? This is center. Okay, what's the circumference? Basically, we have to get the whole, we need the diameter or the radius, right? Because the formula for the circumference is 2 radius pi. Okay, so the radius is given here by x, OX, or OZ. If they give us any of those, then we have the radius. Number 1, they tell you the perimeter of OXZ, so of the triangle. The perimeter of the triangle is 6 plus 3 square of 2. Now, we know something though. This one is a 45, 45, 90 triangle. How do we know that? Because this side and this side, the radius and radius, they are the same length. And this one is a 90-degree angle. So it means that this hypotenuse should be r square root of 2. Okay? Just by knowing that, we have 2r's plus r square root of 2 is equal to the perimeter of that triangle. And they tell you 6 plus 6, so it just fits, right? 2, 3 plus 3 square root of 2 is the perimeter. That's what they're telling me. So the radius is 3. And that's what we needed. We needed the radius. So the first one gives us the radius. Okay? Fairly easy. Now, here, number 2, the length of, let's erase this here. They say, let me change colors to blue. The length of xyz, okay, this is a what we call a arch. Okay, the arch xyz is 3/2 pi. Can we get it from there? Yes. Okay, why? Because we say, okay, 90 degrees, rule of 3 simples, right? Is to this arch 3/2 pi. What 360 degrees would be 2x. Because notice, I mean, this arch corresponds to 90 degrees. The opening of 90 degrees gives you this arch. So 360 actually, you will multiply this arch times 4, right? So basically that's what you have to do, okay? That's what you do. So here's just 1/4. So you multiply that times 4 and you get the whole circumference. Okay, that's another way you get a circumference. So in this case, d, each of the pieces of data independently. So I hope you're enjoying this. If you are, show some love, leave us a comment below, and also, of course, give us a like. Okay, I want you to give us a like right now. So now let's go to the next theory. And now we're going to see the chapter on sets and functions, and this is really cool because here you're going to get a lot of benefit. Okay, most of the questions regarding sets and functions, especially those dealing with 3 sets, right? 3 Venn diagrams, basically are considered really hard on the GMAT, okay? But if you learn the theory I'm about to show you here, they're going to be pretty easy. So you can get those points, all right? You can get those hard questions correct. So let's start. Okay, so now we are going to start with the next chapter, which is sets, all right? So there are 2 types of sets, those of 2 sets and those of 3. The ones of 2 sets are kind of easy. Okay, and so here we have your set. Basically, here we're drawing them with a Venn diagram, right? So you have the sets. The first set is represented by the circle A, right? Which is this whole circle, which includes this A portion and the C portion, right? And then the second set is represented by the set B, which includes the red portion, B, and the yellow one, C, right? And then you have those that fall in neither set, which are inside the frame, inside the rectangle. And that's the total. So the total of 2 sets would be set number 1, complete set number 1, which is this whole thing, okay? Completed. Set number 2, which is this whole complete set here, minus the overlap. So you have to remove C from the equation, plus neither, and there you get your total, okay? So if you memorize this formula, which is pretty basic, you're gonna do okay with this overlapping sets of 2, okay? So now we're gonna go and we are going to tackle this question. All right, it says a liberty test prep here. 300 students prepare for GMAT or the GRE or both. Okay, so you have 300 in total is equal to 300. If 100 of the students are not preparing for the GMAT, okay, how many of the students are preparing for both the GMAT and the GRE? So you have the total is equal to A plus B minus the overlap plus neither, okay? So they say pretty much here 300 students prepare for the GMAT, the GRE, or both, which means neither is 0 in this case. So we're not going to count that up. We just have GMAT, A, GRE, B, and the overlap, which is the overlap, right? Now, we know that T is equal to 300, and we know here 100 of the students are not preparing for the GMAT. They are not preparing for it. So we know that B minus the overlap is equal to actually to 100, right? It's equal to 100. And they ask you, how many of the students are preparing for the GMAT, the GRE, or both? Actually, we can get it right away, right? Because if this is 100, we can get the value for A. A would be what? 200. You see? But then we don't have the way to get the overlap because they're asking you for the overlap. So we already have this. 300 is equal to A, which is 200, plus B minus overlap. B minus overlap is equal to 100. But we don't have a way to individualize the overlap. Okay, so that's what they're asking us for. Number one, a total of 240 students prepare for the GRE. 240 students prepare for the GRE. So what is attained? B alone here is 240. So if B alone is 240, the overlap must be how much? We can get it? Yes, we can definitely get it, because if the B minus overlap is 100 and B is 240, then the overlap is 140, right? So we already have the overlap, so that one's good. Now, 2. Of the 300 students, 60 are not preparing for the GRE. If 60 are not preparing for the GRE, what type of information would that be? Those that prepare only for the GMAT, which means A minus overlap would be equal to 60. If A minus overlap is equal to 60, then you go and say, okay, 200 minus 60 is equal to, actually, let me see here. Yes, I mean, we already know 200, so 200 minus 60 is equal to the overlap, right? So the overlap is 140. You also get it. So in this case, D. You have two ways to get that one, okay, to get the overlap. So it's pretty simple if you know your formula for sets of 2, right? 2 sets. Now, what's more difficult, and this one is a difficult questions tend to use this theory, overlapping sets of 3, okay? For this one, you have to memorize these long formulas here, okay? But rest assured that once you memorize them, this is going to be a walk in the park. It's going to be very easy, okay? So you have 3 sets here, different than the previous one because you only had 2. And the first formula goes total is equal to the 3 sets minus the sum of the overlaps of 2. What are the overlaps of 2? In this case, for example, overlap of 2 is this one here, DG. Another overlap of 2 would be EG. And another overlap of 2 would be GF. Those are overlaps of 2, okay? So you are going to add them up and you're going to subtract them, or subtract the overlaps of 2. And then you have to add G once. Why? Because you discounted it 3 times and that was too much, okay? So you have to add it once again. And then neither are the ones that are outside the circles but inside the rectangle, okay? Then you have a second formula. The second formula goes this way. It says total is equal to AB plus C, the same thing, but minus exactly in 2 groups. So when they say exactly in 2 groups, they are not going to give you DG, EG, and GF. They're going to give you D only, then E, and then F. Those are the ones that are exactly overlaps of 2 sets, right? But not overlaps of 3. So what they're not giving you is G here. Let me change colors so it's a little bit more clear. There you go, G, okay? That G part is not being counted here. Okay, that's why then you have to subtract g, which is this one, g, right, twice. Okay, again, and then neither. Now, what is going to determine which formula you're going to use? Well, it's going to depend on whether they mention the word exactly to or no. If they say exactly to, then you have to use the second formula. If they don't say exactly to, you have to use the first one. Okay, pretty easy. Pretty easy. That's a strategy. You have to memorize this, okay? Because if you don't memorize these formulas, then solving these types of questions is going to be very, very extremely difficult. Okay, it's just totally nuts. So actually, if you memorize this, it's going to be quite easy. So let's go and try that out here. Number 2, take your time, 2 minutes, and then we're going to come back and show you the right way to do it. So here we don't see the word exactly to, right? So we have to apply the first formula. So we go here, total is equal to A plus B plus C minus the overlap of 2, the sum of the overlap of 2, plus all 3, plus neither. Basically, you have that, okay? Now, what is this? You have 20, 30, and 40. 20 plus 30 plus 40, right? They're asking you for the total minus the overlap of 2. What is the overlap of 2? The ones that are in two groups, 5 are in both of us. So 5 plus 6 are in both of us. Okay, 6 plus 9. Okay. 4 workers are in all 3 teams. So then you add 4 plus neither. Let's see if we have neither. Then we don't have neither, right? Neither is 0. Why? Because I say they are placed on at least one team. So nobody is left without a team. Okay, so in this case we have that. So t is equal to 50, 90 minus, what is this? This one is 15, 20 plus 4. So t is equal to 74. Pretty simple if you know your formula, you see? Now this one is actually a hard question, but if you know your formula, it becomes an easy question, okay? Now let's go to the next one, this one. Take 2 minutes and then we're gonna come back. Okay, so in this case, we have the word exactly 2. So that means we have to use the second formula. Total is equal to A plus B plus C, and minus, right, exactly 2. Here minus again, 2 times all 3 plus neither. That's what it is. So actually 20 dogs, 5 belong to A, 5 plus 7 belong to B, and 20 dogs is the total. 7 belong to B, plus 9 belong to C. If 2 belong to all 3 categories, so all 3 is actually 2. So here we have 2 times 2. And 3 belong to exactly 2. So this one's 3. Okay. How many belong to none? So they're asking us for none. Okay, so there we go. 20 is equal to 12 plus 9. Actually, 21 minus 3 minus 4 plus none. 23 minus 21 minus 7 is equal to, okay, so we have 14 plus none is equal to 20. Then we have 6 is equal to none. You see? So in this case, 6. Okay. So how are you liking this? I know you're loving this. So if you're loving this, just support the channel. Okay, you can do it in several ways. First of all, you can subscribe. Of course, I'm pretty sure you already subscribed, right? But besides that, besides only subscribing, also leave a comment and share this video with your friends so the YouTube algorithm doesn't hide this video, because otherwise this video just gets lost. Okay, and I think just like you are enjoying this video, your friends and your family and other people in society also need to get access to such a specialized learning. All right, especially if your dream is to go to business school. First of all, I want to thank all of our students from Latin America, from Europe, and from the United States. Those are the students that usually come to Liberty, and we're very grateful to be able to help them out. Now, if you're watching us from other countries, that's good enough. Also, we're really happy to be able to help you for free. Okay, but you can also show some support, right? And you can also make donations. So now we're gonna go on to the next chapter. So here we have our theory on percentages, okay? And pretty basic theory. Just make sure you truly understand what they're asking you for, okay? And of course, don't forget to subscribe to the channel and click on that notification bell. So right now we're going to start with percentage questions, all right? Percentage is pretty simple, okay? It tends to be an easy theory. After tutoring a lot of students for the GMAT, over almost 1,000 students for the GMAT now, I can safely say that the students around the world, most of them, percentages tend to be one of those easy categories, especially on the basic percentages questions, all right? So most people don't have a problem with percentages. The main thing is to be able to understand that there is an equation, right? So you have X% of a number A is equal to a result B, okay? And you have to be pretty careful as far as to identify what you're getting asked, right? Are you getting asked to and solve for A? Or are you getting asked to solve for X, I'm sorry, or to solve for A? Or are you getting asked to solve for B, okay? So there are 3 possibilities in there that you're going to be asked on. So sometimes because there is a barrier with the language, right? Something gets lost in translation. When people read the question, they don't know what they're getting asked. So for example here, question number 1. What percentage of A is B? Or what percentage of B, or B is what percentage of A, right? So here let's go directly to the example, which is more graphical. 50 is what percent of 200. So here they're giving you numbers and they're asking you what percent. So basically they're asking you for X. They are giving you A, they are giving you B, and of course they're asking you to solve for X, right? What percentage of 50 is what percentage of 200? So actually 50 is the result, the 200 is A here, right? So 50 is B, 200 is A, and then you solve for X. Easy. Now question number 2 is different. A is 5% of what number? So basically they say, let's go to the real example. It says 70 is 50% of what number? So they're giving you the percentage. So they give you X. 70 is 50%. So basically they're giving you the result also. They're giving you B. So in this one, right, question number 2, they're asking you for A. In question number 1, they were asking you for X, the percentage, okay? Number 3, what is 3% of X? Of A in this case, I'm sorry. So what is 50% of 300, for example? 50% of, they are giving you the percentage, so they give you X. They're giving you A, the number you're going to take the percentage from. So this is A. And they're asking you for the result, which is B, Okay, so 3 different questions, 3 different ways to phrase, to word this question. Just be careful that you fully understand what you're getting asked. Okay, that's the first step. If you don't understand what you're getting asked, then we're going nowhere. Okay, now let's start here with number 5. This one's a pretty simple question. So if you take 2 minutes, that's too much. Okay, there's something wrong. So try to take maybe 1 minute, maybe a little less. All right, but you have 2 minutes overall. Okay, and after 2 minutes, we're gonna go and do this together. Okay, so they say the price of a toy increased by 25%. Now, one of the main things I always teach my students is when you are doing the GMAT, you don't want to do this 0.25, okay? You don't want to work with decimals. Decimals are usually restrictive. They don't allow you to do anything else, okay? So if you are going to represent a percentage, what you want to do is to do it through a fraction. So you do 25% that way, okay? That's how we do it. Okay, some people would just start putting decimals, and then there's not much you can do with the decimals, especially if you are just not advanced in quant. Okay, so 25%. The price of a toy is increased by 25%. Okay, let's say the price of a toy is X, and then increased by 25% actually is 100 plus 25%, so it's 125%, 12500, right? So over 100, I'm sorry. So you have 125 over 100. That means that the value of X has increased by 25%, because if you notice, if you say 1X is just that the price is the same, right? So 1X is the same thing as saying 100 over 100X. So basically it means that the price is not moving. It hasn't changed. So if you say 125, right, over 100X, you're saying that it was 25 over. So there's an increase of 25, okay? So that's the first thing. Later, the toy goes on sale and the price is reduced by 20. The price is reduced by 20 means 100 minus 20, which means 80%. Okay, so this is the final price of the toy. So you have initial price, you increase it by 25%, and then you decrease it by 20. So what's the actual price of the toy? What's the current price? So what you do is this one pretty simple, right? You have to try to simplify your fractions. Here you have 5/4, right? And here you have 4/5. Next. Now, if you notice, that's why we love fractions and not so much decimals, right? Because you can easily cancel them out and you're left with X. So, which basically means it hasn't changed, right? The change has been 0. No change. So after increasing 25 and decreasing 20, you are left with the initial price. Pretty simple. right? Pretty simple if you know what to do. Okay, so we're gonna do this one. You have 2 minutes again, and then we're gonna come back and show you the right way to do it. All right, so this one says 10% of the people who took the GMAT this year worldwide achieved outstanding scores. So you have total and you say 1/10, which is 10%, 10 over 100 of that total actually achieved high scores or outstanding scores. Good for them. Among those who did not achieve outstanding scores, 40 had enrolled in preparation programs and 500 had self-prepped. Okay, so let's say out of the ones who didn't achieve, which is a complement out of this one, right? Of this one, so 9/10 of the total, right? The complement, because of course the ones who did not achieve a high score and the ones who did must give you 1, right? 100% of T. So 9/10 of the total, who are the people who did not achieve outstanding score. 40 had prepped, right, with taking a preparation program, and 500 had self-prepped, so self-prep. Now, self-prepping is not a good idea, right? Now, of course, you either prep with a course or you self-prep, which is also, maybe if you don't prep too much, that's also considered self-prepping, right? So basically, this is the total for 9/10 of total. Basically, so this is the actual number for this one. So you're going to add 500 plus 40, and that's going to be equal to 9/10 of the total. Now, with that information, can you get the total? Yeah, very easily, right? So you have the total is equal to 540 times 10 divided by 9, which is equal to 6. T is equal to 600, right? So 60 here, and then times 10, 600. Pretty easy, okay? So these ones are easy questions. So now let's move on here to the next theory, and we have percentage change. All right, percentage change asks you, or actually tells you the difference in percentage between an increase or decrease in a value, right? So variations, increase or decrease of value expressed as a percentage of the original. That's percentage change. Okay, so you have, sometimes the change is going to be represented with a triangle, a delta, right? But in this case, we're just going to say percentage change is equal to change in value, which actually means the new value minus the old value. Okay, so that's what you have. And then on the original value, of course, the old one. And then times 100. Okay, pretty sure you already saw this formula sometime in high school, right? So now, example, the price of a coffee cup increased from 80 cents to 84 cents. So here we have the old price, here we have the new price, and if we want to apply our formula, we go change in value. So the new one 84 minus 80, and in the bottom we have the old one 80. So this is 4 over 80. All right, so what we have here times 100. So there you have a 5% increase. Okay, so it's pretty simple. Now we're gonna go and do one exercise with this. Alright, so now we're going to do this exercise. Again, you have 2 minutes, and after that, I'm going to show you the right way. So here you have an author got $3 million in royalties on the first 20 million in sales of one of his books. Okay. Now, and then 9 million in royalties on the next 108 million in sales. So there's a change to the first ratio. Let's say first, the old one used to be 3 million of royalties per 20 sales, 3 out of 20. The new one is he gets 9 out of 108. So there's a change there. Of course, the first fraction is much larger than the second one. Okay. Now, what was the approximate percent decrease from the first 20 million, from the first one to the next 108? So let's see this one: 3 minus 20 minus 9 over 108 over 3 over 20 times 100. That's what we have. So we first want to simplify 9 over 108. That's the same thing as saying 112, right? So that's out. And then we want to be able to subtract this. So we are going to put them in the, we're going to operate them and just put them in the same denominator, which is maybe 60, right? So 60 here, 9, 60 minus 60, and here 5. Okay, so we have over 320. So we end up having here 4 60s times 320. So we're going to say 23 here, which we are going to just do this 3, which is equal to 5 over 9. And then all of this, of course, times 100, because that's a formula, right? 100 here. So you have 400 divided by 9. Okay. So let's try to do this division. Here we have 9, we to get to 40 we have a 4, right? 36 we have 4, to get to 4 we have 4, 44, 36, and then we get point something. Okay, so we have a 0 here, point 44 point something, which is approximation is 45. Okay, fairly simple and straightforward. Okay, if you know how to do, operate fractions, which is very simple, should be very simple for the GMAT. And also if you remember your formula for percentage change. And now the most dreaded lesson, the most dreaded theory for the GMAT quantitative section. Probabilities and combinatorics, right? These can get very tricky, okay? So just pay very close attention. Make sure you watch every single second of it. Make sure you understand. If there's something you don't understand, just leave us a comment below and we're going to try to get back to you, okay? But just make sure you pay close attention here. Tread lightly. So right now we're going to start with the last chapter for the quantitative course, which is factorials and arrangements, then combinatorics, and then probabilities, okay? It's a chapter that involves all of these theories that are a little difficult, right? These are more advanced theories, but they start off pretty basic and pretty easy. Okay, so factorials and arrangements, of course, we already know what a factorial is. This is a factorial. It's a number with this exclamation sign. So you have the number is n times the consecutive number 1 less, right? n minus 1 times n minus 2 until you get to the number 1. For example, if you have factorial of 7, that's the same thing as saying 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? So these factorials are pretty big numbers. Now, there are some properties here about the factorials. Number 1, the factorial is always positive. There is no factorial for negative numbers. Number 2, the factorial of 0 is the same thing as 1. Okay, it's equal to 1. So factorials greater than 1 also are even. Why? Because they contain 2. Number 2 in the whole operation, right? So if you have factorial of 7, you are going to have factorial of 2. So 2 is an even number, so any number that you multiply times 2 will be an even. If that's a little difficult for you to comprehend, then go back to our number properties theory, okay? Because that's something pretty basic. And then we have factorials greater than 5 have trailing zeros. What does trailing zero mean? It means that they will end with zeros at the end, okay? Why? Because they are multiple of 10, right? For example, take factorial of 7 here. This is greater than 5, right? So it will end in zeros. How do we know that? Because it's a multiple of 10. Why? Because it contains a 2 and a 5 in its prime factorization. You see, it's 2 times 5 is 10, so whatever has 10 in there will end in 0, okay? And then a factorial could be distributed as the number and the factorial of one number less than that. So for example, if you say factorial of 7, that's the same thing as saying 7 times 6 factorial. You see? So that's going to be helpful for us when we work with combinatorics. Now, why do we need to know factorials? Why are factorials important? Because that's going to help us get the arrangements of certain things, okay? So you use factorials to get the number of different arrangements. For example, if you want to arrange 5 letters, arranging means something. For example, if I wanted to arrange 3 letters, let's say A, B, C, I could have A, B, C, I could have B, C, A, I could have A, Z, B, etc., etc., etc. More than that, right? So how do I know in how many possible arrangements I can arrange these letters, right? What is the total number of arrangements? That's given by the factorial. So if you have 5 letters, you do 5 factorial, that's the same as 120. So 5 letters could be arranged in 120 different ways. Okay, that may sound surprising, but that's true. Okay, 4 letters could be arranged in what? 4 times 3, 12 times 2, 24 different ways. 3 letters could be arranged in what? 6 ways. Okay, so that's how we do this. So that's why factorials are important and they're easy. That's a good thing. So now let's go here to this exercise. You're gonna get 2 minutes as usual, and then I'm gonna come and help you out. So 3, 2, 1, let's start. Okay, so in this case, you have how many different arrangements of the letters A, B, C, D, and E are possible, where D occupies the middle position and all letters must be used. So let's say D occupies, so there's a condition here. If there were only 5 letters, like without any restrictions, your answer would be 5 factorial. But in this case, they are making a little difference. They are giving it a little different spin here. They are giving you a condition, a restriction. D has to occupy, so if you have 5 spots, right? D has to be the one in the middle, okay? So actually what happens is, basically they're saying D is fixed. The position of D is fixed. So you have to arrange the other elements. So that's the same thing as arranging only 4 elements. 4 elements are getting arranged, not 5. Which means D doesn't play into this arrangement thing. You just get 4 factorial, which is equal to 24. Okay, 24 in there. That's our answer. Okay, so usually this arrangement, this combination questions are going to come with some restrictions, some conditions, and you have to be able to decipher that. Now this is the most important part, maybe, of the whole lesson. Okay, combinations and permutations. And here we have 2 different formulas. A permutation, the number of arrangements in which order matters. Example, ABC different from CBA. Okay, so if they tell you in how many ways you can arrange ABC, one other way in which you can arrange ABC, or let's say in how many ways you can pick a group of 2. Because when we have permutations, we always have a group. Let's not call this a group. Let's call this a selection of 2. And the group would be ABC. So you have a group of 3 and you want a selection of 2, okay? So if you want a selection of 2, in how many ways can you get it? One possible selection of 2 from ABC will be, for example, AB, right? Another possible selection of 2 would be CB, right? Another possible selection of 2 would be BA. But think about it though. Both AB and BA contain the same number, the same elements, but with different arrangements. So if you believe that AB is different than BA, for example, if they're asking you for a password, right? AB would be different than BA. In that case, you want to get the permutation because order matters. That's what order matters mean. That if you have a different arrangement of the same elements, you're going to get 2 distinct things. Okay, so here is a formula. You have P. N is my group, right? The total group. R in this case is a selection. Okay, so actually you say like P and R is equal to the number of the group in factorial. So in this case, if I wanted to get 2 selection of 2 out of 3, I would say 3 factorial, right? And then the difference between the group and the selection. In my case, the selection is 2, so 3, which is a group, minus 2 would be 1 factorial. That would be my total ways of getting a selection of 2 out of a group of 3. Okay, so let's do this example. Joe can choose a 4-letter password out of a group of 8 letters. How many different passwords can he form? So it's P, group 8, selection 4. So here in the numerator we have the group factorial, right? 8 factorial. Then on the denominator we have the difference between the group and the selection, 8 minus 4, which is 4, 2. And that's the total number of ways in which he can get this selection, okay, from that group with repetition, so basically in which order matters. Okay, now what does the combination do? The combination is a little different. The combination says the combination is a number of arrangements in which order does not matter. ABC is the same as BCA, so both of them are counted just as one. So for example, if you have again ABC, but let's say this ABC stands for names, so people, right? A is Anna, B is Bro, and C is Charlie. Okay, let's say 3 people, and you want to make a selection of 2 people out of these 3. So one way to select would be to have Anna, right, and Bro. Another way to select the group of 3 would be to have Bro, or I'm sorry, Charlie and Bro, right? And what about if I want to select Bro and Anna? Would that be different than selecting Anna and Bro? In this case, it would be the same, right? Anna, bro, bro, Anna. It doesn't matter if you are ordering, if you're arranging the elements differently, you still have the same two people. So in this case, we don't want to, I mean, this one is counted only as one. Anna, bro is the same thing as saying bro and Anna. That's what order does not matter mean. Okay? And in this case, you have to discount this one. Bro and Anna is the same thing as saying Anna and bro. So you cannot count it, or you shouldn't count it as one more. That's what the combination does in its formula. It will discount this repetition so you don't have them in the final result. Okay? Quite easy. So here we have combinations, again, group and selection, right? On the numerator is the same thing. You have the group factorial. The denominator, you also have the same thing you had in the permutation, but the difference would be this. On the denominator, you also have the selection with the factorial. So there is one more thing that you are adding to the denominator, and that's what's making this whole final result smaller. Okay, so example. There are 8 books in the library. How many combinations of 4 different books can you choose? So you have, because we're talking about books, right? I mean, books are individualized things. So we don't want to repeat them over and over. So in this case, the order does not matter, and we have to discount the repetitions. So what we're going to do is this. I mean, we're going to get group 8, selection 4. So we have numerator 8, right? Here, in the denominator, if you have 4, the first 4 is for the difference, right? Difference between 8 and 4. And the second 4 is because of the selection. So with this, you get a smaller number. Okay, so you're discounting the repetitions. That is very important to comprehend, because the first thing you do when you see these types of problems, you have to ask if you want to count the repetitions or you want to discount them, if order matters or if order doesn't matter, because in that way you're going to know when you apply permutations or combinations. Okay, so now we're going to start practicing. Let's go with this one, number 2. Okay, here we have from a group of 3 dogs and 4 cats. So group of dogs, we have 3. Group of cats, double, okay, we have 4, okay? We're gonna create a hit squad. Okay, a hit squad that has 2 dogs, selection is equal to 2, and 2 cats. Selection of cats is equal to 2. How many different squads can be formed? In this case, what do you think? Do we need a permutation or we need a combination? We need a combination. Why? Because these dogs, I mean, they are individualized, right? They have names. So having dog A and dog B is the same thing as having dog B and dog A. So order doesn't matter in this case. So we are going to have to go with the combination. So combination, choosing 2 dogs out of a group of 3. Times. Why times? Because they're saying and. Okay. Whenever they have and, it's multiplication. If they had or, that would be an addition. Okay. But in this case, we're multiplying. So this combinatoric. So this combinatoric, and here we have selection of 2, group of 4. So that's what we get. What is this? This is going to be 3. Okay. What is this? This is going to be 4 times 3. Then you eliminate 2 on the, so that's actually 12. Do you think so? No, because then you have another 2 here, so that's actually 6. So that's the same thing as 18. There we go. Okay. 18, and then we have 3 times 6. Yes. Okay, easy, right? Now let's go to the next one. Oh, okay, here, so they're talking about complements here. So they say there are 10 DVDs on the shelf, of which 4 are comedy and 6 are action films. How many possible selections of 5 DVDs from the shelf contain at least 1 comedy and at least 1 action film? So when they say at least 1, you have to, it's better for you to apply the complement. What is a complement? Basically, you get the total number of combinations, in this case combinations, right, because they're talking about individualized DVDs, right? Total combinations without any restriction, and you're going to subtract the negative outcome. So when they say at least 1 comedy, what is a negative outcome? Because at least 1 comedy, think about it, at least 1 comedy is 1 comedy, right? And no action film, 1 comedy, and I'm sorry, you have to select 5, right? 4 action films, 2 comedies, and 3 action films, 3 comedies, and 2 action films, 4 comedies, 1 action film, and 5 comedies and no action film. And then at least 1 action film is the same thing as this, but without this one here. Okay, so and with this 4 would be, we will be complying with these 2 things. You have at least 1 comedy and at least 1 action film. Okay, but that would require for us to make 4 operations and then add them up. We don't want to do that, so we want to go the negative way. What is the negative outcome? No comedies, right? No comedies and no action films. No action or no action films. So that's that thing. no comedies or no action films. That will be the negative outcome. If we subtract that from the total combination, we are gonna get this. Okay, that's what's left, basically, right? Because if you get all the possible arrangements, right? Let me do this with a different color. You have 5 comedies, 0 action films, and here you have 0 comedies, 5 action films. So these ones are the ones we are gonna get. We're gonna get these 2, then we're gonna subtract it from the total, and we're gonna just stay with the 4, right? That's the only thing that's gonna remain. So that's the best way to do it, because in that case we have to do less operations. Okay, so let's do it. Total combination without restrictions. So you get combination, you want a selection of 5 out of 10, right? Without restrictions. We don't care whether it's a comedy or a action film. Then you're going to subtract the addition of 2 combinations. First of all, the addition, no comedies. No comedies is the same thing as saying all action films, right? So action films are 6. You have selection of 5 action films from the group of 6 action films. So all of them are going to be action films. Plus, no action films. No action films would be the same thing as saying all comedies. Now, all comedies would be what? 4 comedies. Selection of 5 out of a group of 4. Can you do that though? Can you select 5 things out of a group total of 4? No, that's impossible, right? Because you can select a group. In order for you to select, make a selection, the group has to be at least as large as the selection. So this one is 0. It's not possible to have all of them being comedies because there are only 4 comedies. So basically you have this combination of 10 over 5 minus combination of 6 over 5. So let's try to do that. So okay, so let's operate combination of 10 over 5. So you have 10 times 9 times 8 times 7 times 6 times 5 factorial. Here we have 5 factorial, here we have 5 times 3, another 5 factorial, 4, I'm sorry, times 3 times 2. Okay, 5 factorials get eliminated, 3 times 2 is 6, 4, here we get 2, 5, we get 2 also. So here we have 4 times 9 times 7, so that's 63 times 4, 63 times 4, the same thing as saying 60 times 4, which is 240, plus 12, which is 4 times 3, and then you get 252. That's the result for combination of 10 over 5. And then what do we have here? 6 over 5. Whenever you have only one of difference, like the selection is 1 less than the group, you only get the number of the group, so 6. Okay, you can try that out, just try to solve it. And then we go here, 2 is equal to 246. Okay, so that's our answer. Pretty simple. No, it's not that simple, right? This is getting a little harder, yes, but that's what the GMAT is about. This one is not the hardest exercise by far, okay? This one is kind of intermediate, a little harder, but intermediate. There are other exercises that get pretty wild. Okay, now let's go to the next one. All right, so now we're gonna start with probability. So probability is a number, okay, between 0 and 1. So you have like that, your P is gotta fall between 0 and 1. 1 meaning that whatever you want to happen happens always, all the time. And 0 meaning that whatever you want to happen will never happen. Okay, so the probability is a fraction given by the number of favorable outcomes. Success, right? Success outcomes, successful, and then the total number of outcomes, the total number of possible outcomes. Okay, so some examples are this: flipping a coin and getting heads. You want one outcome, the head, out of 2 possible things, because you have head over head and tail. You see? Rolling a dice and getting a 4. So you want one specific number, 4, one specific number out of a group of 6 possible numbers, 1/6. Getting a king out of a deck of cards, you get 4 kings in the whole deck, and here you get 52 cards. So it's 4 over 52, which is the same thing as saying 1 over 13. Okay, so that's what the probability is about. Okay, so now let's continue here to the consecutive probability. So when asked of probabilities in a row, of probabilities of events joined with the word and, now remember, we mentioned this before, whenever you have the word and, that implies a multiplication. Okay, then multiply the probabilities. This type of probability is also called independent because the outcome of one event does not affect the outcome of the others, right? So if you notice that you have, for example, event 1, right? And then event 2, and event 2 has nothing to do with event 1. I mean, basically, it's not affected by the result of event 1. Then that means that you have an independent probability, and you have to add, to multiply, okay? That's the most important thing. So this consecutive joint probability will always be equal to or smaller than the smallest individual probability. So of course, it's gonna get smaller because you're gonna be multiplying numbers that are between 0 and 1. So the more you multiply, the smaller it's gonna get, okay? So what's the probability of getting heads twice in a row when flipping a coin? So first, you get one head. Probability of getting one head when you throw a coin is 1/2, right? Now the probability of getting a second head is independent because the first result doesn't affect, right, my second outcome. So I have 1/2 here too. Now what do? We multiply, and you get 1/4. So the probability of getting 2 heads in a row would be 1/4. Okay. Now what happens if you want to get 5 heads? You get 1/2 times 1/2 times 1/2 times 1/2 times 1/2, which basically is 1 to the 5th, right? Which is 1/32. That's pretty slim. Okay, pretty slim. I mean, you are not gonna get it most likely. Okay, so it's a very small probability of getting 5 heads in a row. Okay, that's different from mutually exclusive events. Okay, because mutually exclusive events means A could happen, but B cannot happen. So it's either A or B. Okay, either A or B. So your outcomes are conditioned. If you get one, then you won't get the other one. Okay, 2 events are mutually exclusive if they cannot occur at the same time. For n mutually exclusive events, the probability is the sum, addition. Usually this is going to be given by OR, right? Instead of AND, you have OR. So that's why either OR here indicates an addition. So you're going to add the probabilities. This type of probability will always be equal to or greater than the greatest individual number of probability, basically. Okay. Remember, whatever you add at the end, it's always going to be less or equal to what? To 1. Okay. Not even the sum of probabilities can be greater than 1. Okay. So example. What's the probability of getting either heads or tails when flipping a coin? Either heads or tails. You're gonna get heads and tails at the same time, right? So it's either heads or tails. So probability of getting heads is 1/2. The probability of getting tails would be 1/2. So the total probability of getting either heads or tails would be 1. Okay? So basically you are gonna get either heads or tails no matter what. Okay? Then number 2, if Jessica rolls a dice, what is the probability of getting at least a 3? So at least a 3, what does it mean? It means 3 or greater than 3. So it could be 3, it could be 4, it could be 5, or it could be 6. So basically you have 4 numbers out of possible numbers out of the total quantitative numbers in a dice, which is 6, right? So it's 2/3. But in order for you to see it a little bit easier, you have here probability of getting a 3 is 1/6. The probability of getting number 4 would be 1/6. Probability of getting number 5, 1/6, and probability of getting number 6, it would be 1/6. You add them all up and you get 2/3. Okay, so that's what mutually exclusive events means. So now we're gonna do this number 4. Again, you get 2 minutes, and then I'm gonna come back and show you the way to do this. Okay, what's the probability of drawing a gold coin and then a silver coin from a jar containing 4 silver coins, 5 gold coins, and 5 copper coins? So the total is what? 14. Okay, that's my total. So here I'm gonna say you want 2 things, right? So I'm gonna the first one here and the second one here, and then say and. So it's a multiplication of 2 fractions. The first fraction is you want to get a gold coin, right? There are 5 gold coins, and there's a total of 14. So my first, getting the gold one, the gold coin would be 5/14, and then you want to get a silver coin, silver. So there are 4 silver coins in total. So I have 4 here. And then on the denominator, I will have 14, but in this case, it cannot be 14. Why? Because the coins are not replaced. So I already took 1 on the first one. So I got to discount that 1 I took on the first one, and I get 13. Okay. So in this one, I got 2, 7. 7 times 13 is the same thing as 91. And here I have 10. 10 91s. Okay. Which is letter B. Okay. Pretty easy, right? Now let's go here to number 5. Alright, so in this one, tickets numbered consecutively from 51 through 250 are placed in a container. What is the probability that a ticket selected at random will have a number with the hundreds digits of 1? So basically they say, alright, hundreds digits. By this time you should already know that when you have a number, for example, 3,902, 9 is my hundreds digit, 2 will be my unit, 0 will be the tens, and 3 will be the thousands, right? So they're asking me about the number 100, right? 100 digit of 1, so 100, anywhere from 100 to 199. Okay. Now let's say tickets number consecutively from 51 to 250. We first want to count how many tickets we have there. So it's 250 minus 51 plus 1. Okay, which is the same thing as 200. There are 200 tickets. Okay, so the denominator is going to be 200. Now, what is the probability of selecting a number with 100 digit of 1? So how many 100 digits we have? 199 minus 100 plus 1, which is equal to 100. Okay, so it's 100. So here's my probability, 1/2. Okay, very easy, extremely easy. Okay, and now we're gonna go here to combinatorics and probabilities. This theory is where it gets really interesting here on the GMAT. The main difference between combinatorics and probabilities is that in a probability, we will have to divide our result by the total number of possible outcomes. Okay, so at the end in the probability, you are going to get a fraction. And that fraction will have to be, in order for you to get the fraction in the denominator, you're going to have the total number of combinations possible without any restriction. Okay, so for example, if they tell us there are 13 animals in a farm, 5 are cows, 8 are sheep. Okay, sheep actually without the S, right? 8 are sheep. Okay, so what do we do here? How many different selections of 3 contain at least one cow? This one, they are here asking us for the selection, different selections or combinations. This is not a probability. Okay, so our number is going to be large. Okay, first, what do you have? Selection of 3 contain at least one cow. Okay, now when they say at least one, I've mentioned the easiest way to go about this would be to go through the complement, right? Complement would be the total minus the negative. In this case, the negative is contain at least one cow. What does at least one cow mean of 3? It means 1 cow, 2 sheep, 2 cows, 1 sheep, 3 cows, 0 sheep, right? And what's the one I'm leaving out? This one that says 0 cows, 3 sheep. Okay, we don't want that. Why? Because that doesn't comply with at least 1 cow. So I'm going to pick this one, all sheep, which is no cows, the same thing, right? No cows is equal to all sheep. So I'm going to discount that. I'm going to get the other 3. So that's the easiest way to do it. Okay, which the operation will be total would be what? You want to get 3 out of a group of 13 minus you want to get all sheep, which is basically you get 3, selection of 3 out of a group of sheep, that is 8, right? So that would be the result. Okay, now if we just do it straightforward, it would be this one. Okay, then here they say combination 5 out of 1 times the combination of group of 8 selection of 2. What is this trying to represent? This is representing selecting 1 cow out of a group of 5 cows and selecting 2 sheep out of a group of 8 sheep. So basically this one's standing for this one. Okay, that's what it's standing for. Okay, so this whole thing is the same thing as selecting 1 cow and 2 sheep. Then number 2, let's go with a different color. All right, here we go to no, let me change colors for the pen here. Combination of 5 and 2 and combination of 8 and 1. So basically, what is this standing for? This is standing for, here we go. Right, so you have 2 cows, right? Let me change colors here also. Okay, you have 2 cows out of a group of 5, selecting 2 cows out of 5 cows and selecting 1 sheep out of 8. So this whole thing stands for this one here. And then finally selecting 3 cows out of a group of 5, 3 cows. So that you are adding them up. Okay, you're adding 3. But of course, in this case, the easiest route would be just to go through the complement. Okay, that's your combination. Now, in the probability, the question is going to change. The question is not going to be how many combinations you have. The question is going to be what's the probability that a selection of 3 contains at least 1 cow. So basically, at least 1 cow is the same thing. You want 1 cow over 2. So basically, you have the same arrangement here in the numerator, this whole thing. Or you could have the complement also, which is the same number. Okay, but then at the end, what you have to do, you have to divide it. So you basically divide all of this here by that total number of possible combinations. So combination of 13 over 3. Okay, so it could be either this one or it could be what we did here. C 13 over 3 minus C, a combination of 8 over 3, and here combination of 13 over 3. That would be the same. That will give you the same result. Okay, but then you have to divide it, and that's that thing. That's what makes a probability a probability. Remember that whatever you do with the probability, your answer should not be greater than 1. Okay, so now let's go and do this number 6. Okay, so they say there are 10 elves in a form. Okay, elves. Out of these 10 elves, 3 have horns and the rest do not. Okay, so 3 horns, 3 elves with horns and 7 without. What is the probability of selecting 3 elves out of a group? 2 who do not have horns, 2 without, and 1 who does. So let's start here. The denominator is going to be the number of combinations without any restrictions. So we get 10, and on the denominator, on the selection, we have what? We want 3, right? 3 out of group of 10, and then we're going to select the 2 who do not have horns. So 2 who do not have horns out of 7 times 1 out of a group of 3 who have horns. So that's the actual operation. So 7 over 2, here we have 7 factorial times 6 times 5 factorial over 5 factorial, which is 7 minus 2, right? Times over 2. So this one's the same thing as saying 7 times 3 is equal to 21. Okay, 21. That's this thing. Then 3 and 1 would be the same thing as saying what? 3 times 2 factorial. Here 2 factorial times 1. So these ones get eliminated and this one's times 3. So my numerator is 21 times 3. Then what about the denominator? We have 10 times 9 times 7, 8, times 7 factorial. Here we have 7 factorial, which is 10 minus 3, and then 3 times 2. 7 factorial gets eliminated, 3 here simplifies 9, 3, 2, simplify. So this one is 3 times 4 times 10. So 3 get cancelled out, and we get 21 over 40, which is answer letter E. All right, very simple, very simple. Alright, so that's been the complete course for the GMAT quantitative section. I know you truly appreciate it, okay? It's been a very big effort to build this course for you, but we're truly glad, guys, because we see your love coming our way, okay? So just keep on sending us love. Also remember that right now we have an ongoing contest to the most loyal and the most active fans of Liberty. And that contest is due on May the 24th. So May the 24th, we're going to announce the winners for the contest, okay? Until that time, stay tuned. We still have to release the lesson for the IR, for integrated reasoning, and that's going to help a lot of people who are taking or are planning to take the executive assessment. So it's been a pleasure to be here with you today. My name is Rod, and we'll leave your test prep, and I'll see you soon.